these are instructions for 9A notes. Today we are going to talk about solving multi-step equations, and at the top of these notes you have listed all steps that you can take when you have any kind of multi-step equation. Now today we are going to be focusing on equations that are a little bit more complicated than two-step equations that we've done in day 7. So let's look at this. How is this equation here different from the one that we were doing previously? In day 7, we had only variables on one side of equation. And when we have variable on just one side of equation, we start undoing what's being done to the variable. We undo addition or subtraction, and then we undo multiplication being done to it. When we have variables on both sides, there are several different ways you can start and solve that equation. However, the recommended one is try to make it to be two-step equation. What does that mean? That means if I don't have one of these variables on one of those sides, I would actually end up with a two-step equation. So the first step would actually be to cancel one of these two variables. I can cancel 3x by subtracting it from both sides, or I could cancel 5x by subtracting 5x from both sides. And I will choose to subtract 3x because if I subtract 3x, I will end up here with positive 2x. If I subtract 5x from both sides, I will end up with a negative 2x on that side. And I don't like to deal with negatives if I don't have to. So my first step will be subtract 3x from each side. And then I write what's left. These two cancel out. I have 9 left. 5x minus 3x is 2x. And I still have plus 3 on that side. Notice now I have just a plain two-step equation where variable x is being multiplied by 2 and added 3. I need to undo addition first by using opposite operation. Do always the same to the opposite sides to keep a balance. And I have 2x equals 6. Now I need to undo multiplication by 2 by dividing by 2. Do the same to the other side to keep the balance. And I have x equal 3. Now to check if my solution really works, I am going back to my original equation, and instead of x in this equation I put 3. So I have this 3 times 3 plus 9 on that side. On the other side I have 5 times 3 plus 3. So what's important for me is when I solve each side separately that I end up with the same answer. If I don't have the same answer, then it means I made a mistake somewhere. It means my x is not 3. It would be another number. So here I am. 3 times 3 is 9 plus 9. That would give me 18. On the other side, I have 5 times 3 is 15 plus 3. That's 18. And now I know that my answer is good. One thing that I wanted also to point to you is this. If you go back to our pouches and coins activity, you know that 3x would be standing for 3 times whatever is in each pouch. So 3 pouches, and then 9 coins, and 5 pouches and 3 coins. Notice when I was taking away 3 pouches from that side, I was taking it from the pouches. I cannot take these pouches from coins, so keep that in mind. You are always matching up coins with coins, pouches with pouches. Let's look at the example. So here I have again variables on both sides. So I need to cancel one of them. That's my first step. I will cancel 6y because if I subtract it from both sides, I will end up with a positive 2y on the left. And I still have minus 3 there. On the other side I have 1. Now I notice I just have a two-step equation where I have multiplying by 2 done to the variable and subtraction of 3. I have to undo subtraction of 3 by adding 3. I have 2y left equal 4. I need to undo multiplication by dividing, and I have y equal 2. And even if I don't do the checking step formally, I can just punch into calculator or in my head check if this works. So 8 times 2 is 16 minus 3 would be 13. 6 times 2 is 12 plus 1 is 13, so I do get the same answer on both sides, so I know that solution is correct. Now let's look at example C. In C example, I don't have variables on both sides. I actually have these two variables that are on the same side of equation. You see equal sign. So they are both on the left side of equal sign. That means I can actually combine those two. 3g plus 2g will give me 5g. I still have plus 6 equal 15. Now I have two-step equation. Undo addition by subtracting. Do the same to the other side. I have 5g equal 9. Then I divide by 5 both sides, and my g is actually 9/5. I can divide that, change to decimal. I can write it as a mixed number, but there is no need for any of that. I can just leave it as a fraction. Now D, what I have here, I have also variables on the same side of equal sign. I can combine them. 6m minus 2m. I should always be mindful of what's being done with a variable. 6m minus 2m is 4m. And then here I have plus 5 and plus 1. What is being done with these numbers? So both are being added, so that's total of plus 6 equal 30. Now I have two-step equation. Undo addition by subtracting. We have 4m equal 24. Divide to undo multiplication, and we have m equal 6. Those are the notes for today.